Hi, this lesson is about double angle formulas and half angle formulas. So we'll start with the double angle formulas. So there are quite a few of them. They're all here in this green box. So double angle, they're called double angle because you'll be taking the sine, the cosine, or the tangent of 2 times an angle. So the sine of 2 times alpha, alpha being our angle, and double it is 2 alpha, is equal to 2 sine of alpha cosine of alpha. So this is, again, an identity, something that's already been proven, which means you can use it for any angle as long as the angle is within its domain. And remember, sine and cosine have a domain of all real numbers. Then for cosine, the double angle formulas for cosine, well, there's 3 of them. So right here, and all of them apply. It just depends on which one you use, will depend on the circumstances of the problem. So the cosine of 2 alpha is cosine squared of alpha minus sine squared of alpha. As a reminder, remember, when you have a trigonometric function squared like that, that means the same as the cosine of alpha squared. It is not the same as the cosine of alpha squared. So the entire function is being squared, not the angle. So that is not true. So we have cosine of 2 alpha is equal to 2 cosine squared of alpha minus 1. That's the second one. And then the third one is cosine of 2 alpha equals 1 minus 2 sine squared of alpha. Then we have one for tangent. So tangent of 2 alpha equals 2 tangent of alpha divided by 1 minus tangent squared of alpha. So you should memorize these. The more familiar you are with them, the easier it is to know which one to use. So here's our first example. We want to derive the formula for the tangent of 2 alpha. So we're going to use something that we learned in the past, which is our sum formula for tangent. And so as a reminder, here's the sum formula for tangent. So if I want to derive the tangent of 2 alpha, well, I'm going to let alpha equal beta so that tangent of 2 alpha is the same as, so I'll just write that here, tangent of 2 alpha is the same as the tangent of alpha plus alpha. And then you plug into this formula right here. So that's what you see in this equation. So I have the tangent of alpha plus the tangent of alpha divided by 1 minus the tangent of alpha times the tangent of alpha. And when you simplify that, your numerator becomes 2 tan of alpha, and your denominator becomes 1 minus tangent squared of alpha. So you get the formula that we were trying to derive. All right. So let's use another formula for cosine. We want to evaluate the given function with the given information. So you want to find the cosine of 2x, so that's your double angle there, 2x is the double angle, if the sine of x is equal to negative 12 over 13, and you are in quadrant 3. All right, so in quadrant 3, remember that both sine and cosine are negative, which is why sine of x is a negative 12/13. In order to use the information that's given, the best formula to apply is the third one regarding cosine, because that one is using sine in the actual formula. So that's indicated here. Cosine of 2x is equal to 1 minus 2 sine squared of x. And so then when in the next line we plug in what sine of x is equal to, well, sine of x is negative 12/13, then you have to square it. And so when you square it, this is 144 over 169, but multiply it by 2, and that's why we get 1 minus 288 over 169. You get a common denominator of 169, leaving you with this. 169 minus 288 over 169, and your final answer is negative 119 over 169. All right, here's another one. We want to evaluate the sine of 4x if the sine of x is equal to 0.6, and you're told that that's in quadrant 1. Remember, sine could be positive in either quadrant 1 or 2, so we are indicating the quadrant to be 1. So notice that sine of 4x and sine of x, the relationship in the angles is that 4x is 4 times the angle x. So it's not a double angle. So we're going to need a couple of steps here to get to what we need. So the sine of 4x, let's just remember what our double angle formula is. The double angle formula for sine of 2 alpha is 2 sine alpha cosine alpha. But remember, I'm dealing with 4x in my problem below. So the relationship between this angle and this one is that 4x is double of 2x. So it's still a double angle formula. So if I apply the formula in the green box above, sine of 4x is 2 sine of 2x cosine of 2x. Okay, but now we have to evaluate using double angle formulas for sine of 2x and cosine of 2x so that I can use the information that's given, that sine of x is 0.6. All right, so remember, again, this is our double angle formula. Sine of 2x is 2 sine of x cosine of x. So in order to be able to use that formula, I have to figure out what cosine of 2x is. So remember, sine of x was given to be 0.6. 0.6 is the same as 6 over 10, which is 3/5. So that's what I'm indicated right here. And again, this is one of those special triangles, one that I asked you to memorize, the 3, 4, 5. So if this is opposite of x and this is my hypotenuse, then the adjacent side is 4, which is where we get that the cosine of x is 4/5. All right, so that means that sine of 2x, which is, remember, this is our formula, is 2 sine of x cosine of x. So that's going to be 2 times 3/5 times 4/5. That works out to be 24 over 25. Okay, but remember, I also need to know what the cosine of 2x is. Okay, so the cosine, that's because I need that here. So cosine of 2x, remember there were 3 options for the double angle formula for cosine, and one of them was 1 minus cosine, 1 minus 2 cosine, actually we're using sine, 1 minus 2 sine squared of x is one of our double angle formulas for cosine. So that's what we applied right here. So it's 1 minus 2, 3/5 squared. And when you simplify that, you get that cosine of 2x is 7/25. So now we're back to evaluating what we're looking for. We want the sine of 4x. Remember, sine of 4x, we wrote this out early on, is 2 sine of 2x cosine of 2x. But we know what sine of 2x is. That worked out to be 24/25. And the cosine of 2x is 7/25. So when you plug that into your formula, you get 336 over 625. And simplified as a decimal, it's 0.5376. Okay, so there's a few steps to that one. You should probably go over it again before you move on. So here we want to evaluate the tangent of 2x, given that the tangent of x is √3. All right, so as a reminder, let's go back to the top. The tangent of 2 times an angle is 2 times the tangent of that angle, so I'm right here, divided by 1 minus the tangent squared of that angle. So remember, we were told that the tangent of x is √3 in this problem. Okay, so all I need to do is plug it into the formula. All right, so here's our formula written out again in terms of x. Tangent of 2x is equal to 2 tangent of x divided by 1 minus tangent squared of x. So this becomes 2 root 3 in the numerator and 1 minus root 3 squared in the denominator. When you simplify the denominator, you get 1 minus 3, which is negative 2. Then the 2's will cancel, and your answer is negative root 3. Okay, so this time we're not evaluating, we're going to simplify an expression. So we want to simplify 4 sine squared of x cosine squared of x. Okay, so none of this looks like one of the double angle formulas yet, but remember, you can write this expression as a product of two expressions. So 4 sine squared of x cosine squared of x is the same as 2 sine of x cosine of x times 2 cosine of x cosine of x. Okay, but that looks really familiar. It actually looks like our first formula. So this is what I mean by memorizing these, because it makes it easier. This looks like this formula on the right side. So I'm going to rewrite it in terms of the double angle formula. So if I go back to our problem, 2 sine of x cosine of x, well, that's the same as sine of 2x. Remember, you double the angle. And then same thing here, the other one also is sine of 2x. So when you simplify this line right here and go to the next line, well, you're multiplying the sine of 2x times itself, so that's just the sine squared of 2x. And we know that that sine of 2x, that's just reminding you that the sine of 2x is 2 sine of x cosine of x. So your answer is sine squared of 2x. All right. This is another simplified problem. So we want to simplify 4 tangent of 4 theta divided by 1 minus tangent squared of 4 theta. So if you recall, and here's the formula, the double angle formula for the tangent of 2 theta is 2 tangent of theta divided by 1 minus tangent squared of theta. So the difference between what you see on the right side here and the given problem here is that it looks like you have doubled the outside, right? And the 4 theta, well, that's double of what you see in here. So there is a relationship. So if I double 4 theta, that becomes 8 theta. And remember, here my coefficient is 1, and here it's 2, so it's half of this. So you end up with 2 tangent of 8 theta. So again, familiarity with the formulas helps a lot. Okay, here we want to simplify. Expansion of any term is not necessary. Proper recognition of the form leads to the proper result. Now, what you're given is 2 sine of 1/2 of x times cosine of 1/2 of x. So 1/2 of x is the angle. And this, again, should remind you of the first formula, the double angle formula for sine. So if the relationship between this angle and the angle in the actual result is that it's double it, then it's 2 times 1/2, which you see here. Then the 2's cancel. So your answer is just sine of x. Okay. Here we need to prove. Remember, when you're proving, you're simplifying one side in order to make it look like the other side. So we want to prove that cosine to the 4th power of x minus sine to the 4th power of x is equal to the cosine of 2x. All right, so we're going to manipulate the left side. So the left side actually factors into these two factors right here. It's the difference of perfect squares. That's cosine squared of x plus sine squared of x times cosine squared of x minus sine squared of x. Okay, but the first product, the cosine squared of x plus sine squared of x, well, that's one of the Pythagorean identities. That has a value of 1, which is what you see right here. And the second one, well, we're just going to leave that as is, but when you look at it, that's cosine squared of x minus sine squared of x. Well, that should remind you of something that we were just talking about. And those are the double angle formulas for cosine. If you recall, there are 3 of them. So if I go back to the top, it's actually the first of the 3 cosine double angle formulas. So cosine of 2 alpha is cosine squared of alpha minus sine squared of alpha. So I have the difference in this problem right here, cosine squared of x minus sine squared of x. Well, that's just equal to cosine of 2x. Again, you double the angle that you see here. All right, so we have another prove problem below. I have cosine of 3x over sine of x plus sine of 3x over cosine of x. We want to prove that that's equal to 2 cotangent of 2x. So just like the last couple of problems, I'm going to simplify the left side. And in order to do that, I'm going to need to get a common denominator. So my LCD here is sine of x cosine of x, which means the first one has to get multiplied by cosine of x, and the second one has to get multiplied by sine of x. That's what you see in this line. And now you have your common denominator. Okay, but the numerator of this expression, this one here, is a sum formula for cosine, which was the previous section. And so if we replace that sum formula with what the formula is equal to, well, that's the cosine of the difference of the 2 angles that you see here, the 3x and the x, 3x and x. Well, it's the cosine of 3x minus x, which we know is the cosine of 2x, because you can subtract those angles. And my denominator, well, that looks like the right side of the double angle formula for sine, except it's missing the 2 in front of it. So we rewrite that as 1/2 of sine of 2x. So you're left with cosine of 2x divided by 1/2 sine of 2x. And so I skipped a step here. That becomes 2 cosine of 2x over sine of 2x. 1 divided by 1/2, well, that's just 2. And cosine over sine, well, that's cotangent. So you get this result right here. Okay. We have another one. We want to prove that the cosine squared of alpha minus the sine squared of alpha is equal to 1 minus the sine squared, 1 minus 2 times the sine squared of alpha. These are both double angle formulas for cosine. So we're basically going to prove that they are the same, that they are equal to each other. All right, for cosine. So on the, we're going to be using a substitution in order to do that. And so the reminder is that we have this Pythagorean identity right here. Cosine squared of alpha minus sine squared of alpha is equal to 1. If you take that Pythagorean identity and solve it for cosine squared, you get this. You get that the cosine squared of alpha is equal to 1 minus the sine squared of alpha. So on the left side, this left side here, you're replacing cosine squared of alpha with this, which is what you see right here. So we have 1 minus sine squared of alpha minus sine squared of alpha. But when you combine like terms, you get 1 minus 2 sine squared of alpha, which is exactly what we wanted to prove. All right. So here's just a slightly different approach to this. We're going to talk about graphing. So we want to determine the amplitude and the period of the function for y equals cosine squared of x minus sine squared of x. So remember, we were able to identify the amplitude and the period as long as your function was of this form, cosine of bx. So this certainly does not look that way, but it's again one of the double angle formulas for cosine. So cosine squared of x minus sine squared of x is equal to cosine of 2x. And now it looks more like this format that we're looking for. So the amplitude is the leading coefficient of cosine. The absolute value of it is 1. And the period, well, that's just 2 pi divided by the coefficient of x, which is 2. And so you get 2 pi over 2, which is just pi. Okay, so now we move on to half angles. The half angle formulas, there's fewer of them that we're going to be concerned with. So half angle means that the angle here is half of the angle that's in the formula. Same thing here. Cosine of alpha over 2, that's half of the angle that's in the formula. So the sine of alpha over 2 is equal to plus or minus the square root of 1 minus cosine alpha divided by 2. And the cosine of alpha over 2 is equal to plus or minus the square root of 1 plus cosine of alpha over 2. So the sign, meaning the plus or the minus, will depend on the quadrant where alpha over 2 exists, as well as your trig function. Remember, sine is positive. Sine is positive in quadrants 1 and 2. So then you'd be using the plus part of the radical in those quadrants, and therefore it's negative in quadrants 3 and 4, and cosine is positive in quadrants 1 and 4, and it is negative in quadrants 2 and 3. Okay, so we'll need to know that information. So here's an example. We want to use the half angle formula to evaluate the sine of 22.5 degrees. So 22.5 degrees, that is the half angle. That's what we're calling alpha over 2 in the formula. So when you plug it into your formula, and I'm using the top one, I'm going to be using the positive part because 22.5 is in quadrant 1. But the angle that you're taking the cosine of, you have to double that. Remember, the relationship between this and this is that alpha over 2 and alpha, depending on your perspective, alpha over 2 is half of alpha, but alpha is also double of alpha over 2. So that's why we multiply this by 2. So that leaves us with the square root of 1 minus cosine of 45, because 2 times 22.5 is 45 degrees divided by 2. But the cosine of 45 degrees is root 2 over 2. That's something you should know from memory. Then we have to simplify this. So in your numerator, you need a common denominator. So I rewrite 1 as 2 over 2 minus root 2 over 2. And don't forget about the 2 in the denominator. So 2 minus root 2 over 2 divided by 2. These 2's in the denominator and this one combine to 4. So you end up with 2 minus root 2 over 4 simplifies to the square root of 2 minus root 2 over 2, because the square root of 4 is 2. So that would be your exact answer. But if you needed to approximate it, you'd need a calculator. And so you get 0.3827. So for the prior step is the exact answer, and this is an approximate answer. Okay, so we'll do another one. We need to find the half angle formula to evaluate the cosine of 112.5. And then we're going to find both the exact value, as I explained before, and the rounded answer to the, actually, we're going to make this to the 10th thousandths place. We did before. Okay, so I have the cosine of 112.5. Again, remember 112.5 is the half angle. So when you plug it into the formula, you need to double it, which is why you have here the square root of 1 plus cosine of 2, 112.5 degrees divided by 2. And this time we put a negative in front because cosine is negative at 112.5 degrees. You are in quadrant 2. All right, so when you double 112.5, you get the cosine, 1 plus the cosine of 225 over 2, and we're taking the square root of that. 225, that's in quadrant 3. Okay, so this is 225 degrees. The reference angle is 45. So since the reference angle is 45, this is negative root 2, and so is this in quadrant 3. So what you plug in right here is that it's negative root 2 over 2. Then you get a common denominator as we did before. So I get 2 minus root 2 over 2. And when you simplify, because this becomes the square root of 4, that becomes 2. So your exact answer is negative square root of 2 minus root 2 over 2. And so that's your exact answer. And when you use a calculator to approximate it, you get negative 0.3827. Okay. So we're going to use the half angle formula to find the exact value of the sine of pi over 4. Now we already know that that's equal to root 2 over 2. It's something you should have memorized. Pi over 4 is 45 degrees. But we're going to show that with our half angle formula. So our half angle formula says that the sine of pi over 4 is the square root of 1 minus cosine of pi over 2. Remember, this is the half angle to this. So if you double pi over 4 times 2, you get pi over 2. Okay, so 1 minus the square root of 1 minus the cosine of pi over 2 over 2. Remember, the cosine of pi over 2, that's a quadrantal angle, and the cosine of pi over 2 is 0. So you get the square root of 1 over 2, but you have to rationalize it to make it look like what we're accustomed to seeing. So multiply top and bottom by root 2 over root 2, and you get that your answer is root 2 over 2, which is the answer we expected. Okay. This time we want to simplify the expression using the half angle formula, and then we'll use a calculator to see what the actual answer is and verify that it makes sense. So here I have the square root of 2 minus 2 cosine of 328 degrees. So in reality, you could do this right away with a calculator, plug that in, and you would get this as your approximate answer. So now we're going to see if the half angle formula leads us to the same result, and it should if we do this correctly. So this doesn't exactly look like the half angle formula, but it could be manipulated a bit. So here I'm factoring out a 2. So I have the square root of 2 times 1 minus cosine of 328. Then I factor out that root 2. So I get root 2 times 1 minus cosine of 328. Okay, but this should look familiar to you because I do have a square root of 1 minus something. So that's my half angle formula for sine. So sine, just going to write that down here. So sine of alpha over 2 is equal to plus or minus the square root of 1 minus cosine of alpha over 2. Okay, I have a minus there, so that's how I know that I'm using the half angle formula for sine instead of cosine. So here, if I multiply both sides by root 2, I get the root 2 sine of alpha over 2 is equal to plus or minus 1 minus cosine of alpha. So that's exactly what I have here, is I have just the 1 minus cosine of an angle. Okay, so now I have to replace that by something. So remember, 328, that's double the angle that's in the formula. So half of it is 164. So when I make my replacement, I get root 2, so that's this root 2, times root 2, which is the one here, times the sine of half of the angle. Remember, this is half of the angle of what's inside the formula. So that's sine of 164. But root 2 and root 2 is 2. So I get 2 times the sine of 164. And if you were to plug that into a calculator, make sure you're in degree mode, you get the same answer you did the first time. Okay, so here's another one. We want to simplify the given expression using a half angle formula. So I have the square root of 1 plus the cosine of 98 degrees over 2. All right, so that's the half angle formula for cosine. So this is the right side of the formula. And remember, the right side of the formula that's in the box above is double the angle that's on the left side. So 98 degrees and 49 degrees, you got to divide the 98 degrees by 2. So the cosine of 49 degrees is 0.656. You would get the same answer if you plugged this into a calculator. You would also get 0.656. Okay, so let's move on. I want to use the half angle formula to simplify the square root of 4 plus 4 cosine of 8 beta over 2. All right, so first thing I'm going to do is factor out a 4. And that leaves me with 4, the square root of 4 times 1 plus cosine of 8 beta over 2. 2 goes into 4 twice. So I have the square root of 2 times 1 plus cosine of 8 beta. The root 2 can come out. So you end up with root 2 times square root of 1 plus cosine of 8 beta. Okay, but again, that should remind you of one of our formulas. So the formula is that the cosine of alpha over 2 is equal to plus or minus 1 plus cosine of alpha over 2. And if you multiply both sides by root 2 of cosine of alpha over 2 is equal to plus or minus 1 minus cosine of alpha. Okay, so then this piece gets replaced with what you see here. So it's half of the angle, which is 4 beta multiplied by root 2. So I have root 2, this root 2, times this root 2 that's here, times the cosine of 4 beta, and root 2 and root 2 multiply together to give you 2. So you get 2 cosine of 4 beta. Okay, here's another one. We want to use the half angle formula to simplify the square root of 2 minus 2 cosine of 16x. So again, you need to use a half angle formula. There's a minus in between, so I know I'm using the half angle formula for sine. And if I multiply both sides by root 2, you get this formula right here. Root 2 of sine of alpha over 2 is equal to 1 minus cosine of alpha. All right, so here, first I factored out a 2, then I wrote this as root 2 times 1 minus cosine of 16x. This 1 minus cosine of 16x looks like this. So the relationship in angles is that 16x here, this would be the 16x, and this one out here is half of it. So that's why we end up with root 2 times root 2 sine of 8x. Remember, 8x is half of the 16x. Root 2 times root 2 sine of 8x is just 2 sine of 8x. And that's your answer, simplified. All right, so let's do another problem where we have actual numbers to plug in. So we want to find the value of cosine of alpha over 2 if the sine of alpha equals -4/5 and it is in quadrant 3. So it's alpha between 180 and 270. So that is quadrant 3. So if we use the Pythagorean theorem, we can easily find the value of cosine. Remember, this is -4, this is 5. With the Pythagorean theorem, you get that this is -3. So therefore, the cosine of alpha is -3 over 5. So the cosine of alpha over 2 is equal to negative, and we know it's negative because I'm in quadrant 3. It's negative the square root of 1 plus cosine of alpha, but cosine of alpha is negative 3 over 5. When you get a common denominator, so here you're going to be doing 5 over 5 minus 3 over 5, and that's 2 over 5, and that's what you see right here. So negative square root of 2 over 5 divided by 2, well, the 2's will cancel, and you get negative 1 over 5, and if you rationalize it, you get negative root 5 over 5. Okay, we'll do another one, the last one. We want to find the value of the sine of alpha over 2 if cosine of alpha equals 0.4706, and you're told that alpha is in quadrant 4. So quadrant 4. Since alpha is in quadrant 4, we know that half of that will lie in quadrant 2. If you take half of these two values, you end up with a value that's in quadrant 2, and sine is positive in quadrant 2. So your sine of alpha over 2 is equal to the square root of 1 minus the cosine of alpha, which is 0.4706 over 2. You use a calculator to estimate this value, and you get that the value is 0.5145. So now you're ready to try the homework for this section. Good luck.